Hello and good afternoon to everyone. Dear ladies and gentlemen, I wish you a warm welcome from the room in sunny and warm Zagreb with a nice view to the river Sava, which is flowing to the city of Belgrade here from Zagreb. And then I would like to introduce our speaker, Dr. Marina Babic Mladenovic, from Jaroslav Cerny Water Institute from Belgrade, Serbia, who will tell us something about rivers, and she will give us a nice lecture on river engineering in Southeast Europe, benefits and faults. Rivers as mountains are very precious to us in Southeast Europe, in the Balkans, and lots of us are related to rivers personally or in real life. And we know that water as energy is also important for sustainability. And as Professor Kupusovic said in the introductory lecture, we need to cross the river. We don't know if the poet was thinking about the real river that we need to cross, but today we will hear how we can cross real river on sustainable way, because rivers are important to us, not just as a source of water for irrigation or everyday purpose, as a source of energy or navigation. We know that they are supporting our ecosystems, and biodiversity is also important there. So we will hear how we can cross this river sustainably, and that we left them for the future generations to enjoy in them as we were enjoying it today. So I think we have the most distinguished lecture today for this topic, because Professor Marina Babic Mladenovic graduated at University of Belgrade in Faculty of Civil Engineering, and her specialization is in hydraulic engineering. She defended PhD with the title "The Effect of Reservoirs to Sediment Regime of Alluvial Rivers, Case Study of the Iron Gate Reservoir," which is a very beautiful place on the border between Serbia and Romania, if I'm right. That is really nice spot, and I will recommend everyone to go to see how the nature is there preserved, but also how it's utilized for the benefits of whole region with much more potential. Then as a very distinguished researcher, Professor Mladenovic made her career becoming assistant in the Water Cerny Institute, then senior researcher, then leading the departments, and finally until till December 2019 she was also director of the institute. So we can see that Professor Mladenovic was involved in many projects and international commissions, and she had until now very fruitful career with more than 130 papers published in hydrology, operation of water management system, hydraulics, transport of pollution, sediment and ice, natural water courses, hydromorphology, water management, flood risk management, and also recently, which is I think also the crown of career, when you can publish the book of river engineering, which is in the Serbian language, but this language is quite understandable in the region, and I hope Professor Mladenovic will also translate this book, so it will be offered to the wider public. Professor Mladenovic, floor is yours. Please tell us more about our rivers, maybe what we don't see, and how we can preserve them and use them sustainably. I would just like, before I gave you the floor, just to remind the attendees to send their questions in the text in the chat, or they can raise hand, and all this lecture will be taped and available on YouTube online, so it's also accessible later. But if you are joining us with your question, then you will also be recorded. So this is just a reminder. Thank you, everyone, and Professor Mladenovic, please.
Yes, thank you. I'm starting. My name is Marina Babic Mladenovic. I'm coming from Serbia, and I would like to present the river engineering in Southeast Europe, specifically in Serbia, and its benefits and faults. In all parts of the world, including Southeast Europe, along or across rivers. The river engineering, including flood protection, became more and more complex over time, and increasingly stringent criteria were set for the protection of the growing number of people and continually increasing value of assets in flood-prone areas. The river engineering is the process of undertaking planned activities to alter a river course, riverbed characteristics, or the flow regime in order to systematically reduce damages caused by floods or riverbank erosion, to create conditions for the use of rivers for navigation, water supply, hydropower generation, irrigation, and the like, and protect or promote the river and riparian environment. The response of the nature on river engineering works is difficult and often impossible to fully predict. Now, the planning of river engineering measures tends to be integrated, sustainable, and multidisciplinary, and also considering the environmental and social issues. This lecture includes a number of examples of the past river engineering projects. The hydropower and navigation system on the Danube River, the hydropower plant Zvornik on the Drina River, and the draining of the Velika Morava River upstream of the mouth to Danube. The first part of this lecture is about the effects of the Iron Gate or the Gerda reservoirs on the Danube River environment. The Iron Gate water power and navigation system was completed in 1972 by joint efforts of Yugoslavia and Romania. The dam of the Iron Gate 1 was constructed on the kilometer 942 of the Danube, and it created one of the largest reservoirs in Europe with a total drainage area of more than 500,000 square kilometers. The main purpose of the system was to utilize the considerable water power potential of the Danube and to improve the navigation on a previously difficult reach of the river in the Gerda Gorge. In 1985, a second dam was built 8 kilometers downstream from the first one for additional power production and more flexibility in the joint operation of the two power plants. Each dam of the Iron Gate includes 2 navigation lock, an earthen non-overflow dam, 2 hydroelectric power plants, an overflow concrete gravity dam, and many other facilities. The construction of the Iron Gate 1 began in 1970, and it was the huge effort of both countries after almost 20 years of investigations, studies, and designs. The Iron Gate 1 reservoir spreads on a complex river system. At low flow, backwater extends more than 300 kilometers on the Danube, on the Sava and the Tisa rivers, while on high flows, backwater extends about 130 kilometers. In comparison to the Danube flow, reservoir has a small volume and hydropower plants runs as runoff river. The downstream reservoir is small, 80 kilometers long part of the Danube between two large dams. Further, I will discuss only the upstream reservoir. It has a variable height of water levels and the extent of backwater. During high flows, the water elevation at the dam is higher than in natural conditions, about 90 meters, and the backwater extends to the mouth of the Nera River, where the border of Romania is. During periods of low flow, the water height of the dam is 33 meters, and the backwater extends to the Danube and these big tributaries, Sava, Tisa, and Morava. The reservoir has low longitudinal gradients, and also the characteristics of the riparian terrain and the river channel are very different along it. The Iron Gate 1 reservoir has two distinct parts. The downstream part is in the famous Gerda Gorge, where the backwater affects only some localities, small settlements, roads, and high river banks. The upstream part of the reservoir extends through lowlands and impacts the river, groundwater, and inland water regimes. The water management problems caused by erection of this reservoir were early recognized and adequately addressed by comprehensive protection works and measures. More or less, they are concentrated within the Iron Gate 1 riparian area. But from the very beginning, the regular monitoring and studies of the reservoir's environmental impacts were done, and it comprised 9 different programs. The Yaroslav Water Institute developed a comprehensive multidisciplinary program for the monitoring, measurement, and analysis of the reservoir impacts. There are 9 specific sub-programs for the monitoring of river flows and backwater levels, groundwater levels and drainage system operation, sediment regime and deposition, ice regime, agricultural land conservation, forests and wetlands, flood control structures, quality of water and sediment, riverbank and landslide stability. For each problem, types and scope of investigations were initially defined, but in the course of their implementation, many adjustments and modifications were made. The monitoring started in 1974 and it is ongoing. Monitoring of river flow and backwater levels is a basic program comprising field measurements of water levels and river flow on numerous stations and annual and periodic reports, including a comparison of measured and designed backwater levels. The Iron Gate riverine areas are protected from the adverse effects of the high groundwater levels by suitable structures and systems. Those are drainage wells, pumping stations, and so on. Within this program of monitoring, the groundwater levels and functioning of protection systems are monitored, as this is a special precondition for any land use in the riverine areas. There are 94 systems in operation, mainly in the upstream part of the reservoir. And on the next slide, I will show points and profiles on the Kovin-Dubovac area. In the Kovin-Dubovac area, the protection system consists of the open drainage channels with artesian drainage wells, built along and pumping stations. Groundwater levels are monitoring on numerous piezometers, yellow painted points. Red lines are profiles used for calculation of groundwater levels. As you can see on this slide, there are different ways for protection of the agricultural areas and urban areas. The agricultural areas are protected with drainage channels and somewhere with channels with wells, but the urban areas are mainly protected by lines of drainage wells which are built along the river banks. The comprehensive field investigations of the sediment along the Danube and its tributaries were done in the 60s. And then the forecast was done in the design phase of the Iron Gate 1, and it indicated that significant modification of the Danube sediment regime would be expected, although development of sediment deposits would be relatively slow, and that such dynamics of sediment deposition will leave us sufficient time for remedial measures to be undertaken in the reservoir or in riparian lands if needed. The sediment monitoring program within the Iron Gate 1 was launched in 1974, and it includes water discharge and suspended load measurements, which are done occasionally 2 to 3 times per year. Suspended sediment concentrations measurements are done daily on a number of points. Bed load measurements were abandoned. Bulk density of deposit sediments was investigated 2 times in the Iron Gate 1 reservoir, and also the cross-section survey was done a few times every 1 to 5 years. This slide presents the areas where the suspended sediment in the Iron Gate 1 reservoir is monitored. The red dots are present monitoring cross-sections, while the yellow ones were used in some period and then abandoned. Every day, the samples of water and sediment are taken from the river, and 2 to 3 times per year, the cross-sectional measurements are done from the boat. These cross-sectional measurements are used to calculate the average suspended sediment concentration in the river cross-section, and then the sediment transport. Data from 1 year are used to make a balance of the suspended sediment within the reservoir. Sediment transport and deposition processes in the Iron Gate reservoir depend on a large number of natural factors as the size and natural characteristic of the Danube Basin area upstream, its major tributaries, geomorphological and morphological characteristics of the Danube. But also there are man-made influences as controlled backwater regime of the Iron Gate hydropower plant. The backwater, in the backwater zone of the Iron Gate, the upstream part, the influence of hydropower plant is relatively small and felt only during low to medium flows. Sediment transport during period of high flows is the same as in natural regime. Major influence are sediment delivery by the Tisa and the Sava and conditions on their mouths. The immediate or downstream part of the reservoir has intensive sedimentation. The high sediment deposits are formed in one part of the reservoir, which are present on the next slide. Immediate Iron Gate reservoir, which is downstream of the kilometer 1075 or the mouth of the Nera River, cause intensive sedimentation. The highest sediment deposits were formed between the kilometer 970 and 1003, which is in the vicinity of the town of Donji Milanovac, where the channel expansion in the Iron Gate Gorge acts as a natural sediment trap. All river cross sections in this area show significant change. There is a permanent increase of floodwater levels upstream of the reservoir, which is induced by sedimentation. At the area of Belgrade, it is presently about half a meter, downstream up to 1 meter. And this issue is very important because these are lowlands of Serbia where the life itself depends on the protection from floods. In 2006, there was an extraordinary difficult flood defense because many cities along the Danube were endangered by extremely high water levels. And this flood defense lasted for 2 months, and it was very important to build new levees above the existing because the flood levels were about design. The problem of the ice on the Danube and its tributaries is known, including relatively frequent critical situations. The construction of 2 dams and the operation of hydropower plant changed the natural conditions of ice formation and movement. Monitoring is organized during cold winters in order to obtain relevant data and establish appropriate techniques for ice control in the backwater zone and coordination with neighboring countries. These are the pictures from the recent winters in 2012 and 2017, when we had very serious conditions of ice, especially upstream of Belgrade, and these red areas show that the ice defense lasted for 1 month and more. The reservoir had the impact on the forests in the vicinity. On minor and downstream parts, forests are devastated after the impoundment. Upstream, the impact was monitored at the number of points. These are these red points within the reservoir range. 40 years of monitoring revealed that these upstream forests endured prolonged flooding. This slide presents sites for monitoring of soil salinity within the Kovin-Dubovac area. This program revealed that the process of soil salinization is weaker than expected by area and intensity. Monitoring of flood structures during and after high flows due to high flood risk of low-lying riverine areas is a permanent and very important task. After 2006, a reconstruction to meet higher design flood levels started. It was expected that the water quality in the reservoir will be lower because of high water levels, low velocities, reduced purification capacity, and it was also anticipated that sedimentation might threaten the ecosystem due to accumulation of hazardous and harmful substances. That is why the water and sediment quality is monitored every year on a number of points which are presented in this map. Regular monitoring of water and sediment quality started in 1985. Presently, we are doing twice a year sampling and analysis for 8 sampling sites and twice per year at 12 sites on the longer river reach. The investigations also include hydrobiology, phytoplankton, zooplankton, bottom fauna, phytobenthos, and a large number of quality parameters. It can be stated that the water quality is still satisfactory due to high capability of self-purification, although it changes as a consequence of incoming load, hydrological conditions, and water temperature. Nature of water habitat has changed both in composition and population density. Monitoring of still and active landslides in total 26 locations and other riverbank instability phenomena is done on the right bank of the Danube every year. There is a large number of historical monuments, including 2,000 years old Neolithic settlement of Lepinski Vir and numerous monuments from Roman times. Particular efforts were made to save these monuments from raised water levels. There are also important medieval cities along the reservoir impacted by high water levels where protection had to be done. There is an abundance of natural resources along the banks of the Danube. These are oases of conserved nature, including rich and diverse plants and animal life and resources under special protection. Large aerial entities were protected by declaring a special regime, including marshland of Kovi and Petrovardin, Obed wetlands, Dubovac marshland, and the Đerdap National Park. There is also one new area which was created by the Iron Gate 1 dam construction, and now it is the important stopover site and wintering area that attracts the largest congregations of water birds anywhere in the region. But it must be mentioned that the Iron Gate dams interrupted the fish migration, and there are coordinated activities in the recent times where Serbia is cooperating with the Romanian side, the ICPDR, and other international institutions regarding restoration of fish migration for sturgeons and other species. At the end of this part, some conclusions. The hydropower and navigation system, Iron Gate 1 and Iron Gate 2, is one of the largest in Europe. The objectives of the Iron Gate project, which is utilization of the considerable water energy potential and improvement of navigation conditions on previously very dangerous Serbian-Romanian section of the Danube, are completely achieved. In the operation period, this system has proved its necessity. Without the production of this system, the energy supply of Serbia and Romania could not be realized at all. The navigation conditions are also completely improved because the navigation is possible all over the year and all previous constraints and dangers have been suspended. On the other hand, the hydropower and navigation system or these two dams has major environmental impacts which are permanently monitored. The monitoring program provides information and data on the status of the reservoir and the riparian belt, as well as on the efficiency of protective measures. The recommendations are given for additional works and measures and assessments of possible alterations of hydropower plants operation mode. There is a need for continuing monitoring of these impacts on both the reservoir and the riparian land under the existing or modified prop. Also, some good things have to be mentioned. The ice regime is better in the reservoir than it was in natural regime. The slope stability is less compromised than expected. There are good environmental conditions, such as establishing or promoting the extraordinary natural quality areas. Infrastructure is constructed in the riparian areas, roads, municipal objects, and gives a great contribution to the region development. And also the system for protection of riparian lands provides good conditions for agricultural production. The second part of this presentation is on the effects of the Zvornik reservoir on the Drina River environment. The Drina River is the largest tributary of the Sava River, which is in turn the largest tributary of the Danube. The Drina itself has the surface area of 19,680 square kilometers and spreads over the territories of 3 main Riparian states, Bosnia and Herzegovina, Serbia, and Montenegro. Also, a very small part is in Albania. This river basin is large, prevalently mountainous, with only lowlands near the mouth to Sava. It is mostly covered by forests and has a very dense hydrographic network. The rain in the Drina River basin significantly changes from the upper part towards its confluence to the Sava at the north. The southern part is hilly and mountainous, particularly in the Montenegro. The northern parts are plains of Semberia and Machla. On these slides, you can see the difference between the upper and middle course and its lower course, where the river has alluvial character. At the upper end of the lower Drina course, the hydropower plant Zvornik was built in 1955. After that, 10 years later, another hydropower plant on its middle course was built. It is Bajina Bašta. And the last one is hydropower plant Visegrad on the upper course, built in 1988. The initial volume of this reservoir was 95 million cubic meters. Until 1966, when the upstream Bajina Bašta reservoir was built, the reservoir lost 30% of its initial volume. The latest survey was done in 2005 and revealed that its volume is reduced to 41 million cubic meters, which means that more than 50% is filled with sediment. The sedimentation is clearly visible since large islands and bars are formed. Since the Zvornik dam completely interrupted the bedload inflow into lower Drina section, it suffers from the lack of sediment. The riverbed is extremely unstable and has irregular changes. Manifestations of fluvial erosion are very visible and intense, and banks may shift for tens of meters in a very short time. Erosion of outer banks is present on almost all river curved reaches. The sediment deposition in the form of large sediment bars is a parallel process or inner banks. Of course, there are other things that influence this extreme river behavior. There are irregularity of hydrological and hydraulic characteristics of the stream due to hydropower plant operation. Also, geological composition and geomechanical characteristics of the terrain, where the alluvial deposits are 12 meters thick. Also, the exploitation of sand and gravel from the riverbed and various structures that may influence the flow pattern. At the end, all this sediment reaches the Sava and forms a huge sediment bar on its mouth. This sediment bar is an obstacle for the flow of the Drina and also the Sava, where navigation is endangered due to this bar, which is narrowing the navigation channel and provides the obstacle for the especially upstream navigation. Third part of this lecture is about the deepening of the Velika Morava riverbed. The Morava River Basin is the largest national river basin in Serbia. It covers 43% of the country. It drains the southwestern part of Serbia, and the Velika Morava is the largest river formed by confluence of two rivers, the Južna and Zapadna Morava. It is also the right tributary of the Danube within the Iron Gate 1 reservoir. The Velika Morava is the lowland alluvial river. It used to be a meandering river, but after training works, which included 16 meander cutoffs, the length of the river is reduced by approximately 20%. And also important information, it was used as a source of gravel for construction for many decades. The most downstream part of Velika Morava is heavily regulated. It has the embankments on both river banks on the length about 30 kilometers and many river structures within the riverbed. The water levels in the river are dropping in the last decades. They are measured at the gauge station Ljubichevsky Most, about 22 kilometers upstream of its mouth, and from 1950s up to today, the water levels dropped approximately 4.5 meters. At the same time, the suspended sediment transport was reduced from 6 million tons in 60s to present 2 million tons, according to the observation at the same Ljubichevsky Most gauge station. Also, the lowering of a groundwater table in the riverine areas of this section of Velika Morava is observed, and it causes the huge water supply problems in the nearby Ključ water source. Riverbed degradation is going on, and we know that it is caused by draining of the riverbed, the cutoff of meanders and river structures on both banks, which result in deepening of the riverbed. And also that the sediment regime is the cause of that because it is changed due to retaining of the sediment in the number of reservoirs built in the river basin, the changed land use pattern in the river basin, the huge amount of anti-erosion measures, and permanent dredging of sand and gravel. But still, we don't know which measures can be taken to prevent further degradation of the riverbed. If you have any questions, I will be happy to answer.
Thank you, Professor Mladenovic, for this very informative presentations. I think you covered the most of the biggest rivers in Serbia and also the region in Southeast Europe. I would like to open the floor for the questions. There are no questions currently, but I would like to ask you about this water energy nexus, which is becoming more and more important. And you mentioned several functions of our rivers, but I know there are even plans for more development of energy facilities like dams especially in maybe Drina, but also in Iron Gate. If there was some talking about this reversible hydropower plant, so like Đerdap 3. Do you know what is the status of this project and also the status of Drina project? If you're
the Đerdap 3 is a reversible hydropower plant. It is still only the idea. So there are no designs, no studies. And I think that it will never be finished because the only place to make the reservoir are in the Đerdap National Park. And it will be, since it is protected, I don't think that it will be possible to do that. So that's my opinion. because the idea is very old and it is still pending. I think it will be like that forever. Although it is a pity because the Danube has such a huge discharge that can be used for this production. I don't know. On the Drina, the development of new hydropower plants will start soon. A few days ago, it was announced that the hydropower operators from Serbia and Bosnia, the Republic of Srpska, have joined their efforts and that they will start to build new 3 hydropower plants on the upper Drina course, so upstream of the Visegrad. And I think it will last for decades, but the initial step is done.
And regarding the current planning of these new hydropower plants, do you have information? Are they planned according to the latest knowledge in this river basin planning and providing the most? Or, for example, I know some hydropower plants in Croatia that they were built with you know, not so novel technology or not so novel protection of river basins. So this is something that
I'm not sure. I'm not involved in that design, so I cannot say what is that.
Okay. We have a question from Professor Serra from Brazil. Can you tell it, Professor Serra? Or
what is the profile of navigation on the Danube? The Danube is the international waterway. There are 14 countries along the Danube which can use it for navigation. It is open only for riparian countries. Presently, it is not used for navigation as it can be. It is very, very good conditions, especially through Serbia. But we are trying to promote this kind of the transport because it is environmentally friendly, I can say.
yes. If there are some more questions, please, you can also raise your hand and then.
Yeah, we have Goran Strunjek waiting.
Okay.
So my name is Goran Strunjek and I'm come from Faculty of Mechanical Engineering and Architecture. I have one question regarding, and first of all, thank you for your informative presentation. So I have a question regarding the reservoir levels of the hydropower plants. When I was doing work on my study for the master's degree, I had a lot of problem of finding the data for the reservoir levels of the hydropower plants. So maybe you can share with us sources where you found those and where we can find it for our future studies. Thank you.
You would like to use that kind of data for something. So I can say about the Iron Gate. The Iron Gate is, there are so many measurement stations on the dam side, downstream, on the Romanian side, on Serbian side, upstream. So because the gradients on the Danube are very, very low, so every centimeter means millions of dollars. So they are measuring it very, very precisely. I don't know if these data are open to public, but you can write, if this is for some scientific research, you can write me an email and I will try to make a connection with the Iron Gate Hydropower Authority. I hope that they will provide you this data for science, of course.
Thank you.
Thank you.
I have one quick question, if it's not a problem. So you mentioned that the river level dropped down over the last 50 years for more than 4 meters. So what is the main reason for this? I'm not sure, maybe you mentioned it, but I missed it during the presentation. And how does this influence the annual electricity generation from the power plant Djerda?
Well, this drop of the water levels is on the tributary of the Danube. So Velika Morava is its tributary. The influence on the Djerda production, there is no influence. But we have huge problems with the water supply because there are a few cities that used which are using the groundwater from this huge well. And because the water levels in the river are dropping, the groundwater is dropping accordingly. I tried to find the one reason, but there is no one reason for this river deepening. So there is a combination, and I wrote it on the last slide. So it is the river training, the river basin, land use, anti-erosion works which stopped the sediment income into the river. So many different things are happening, but it is not only here on Serbia. These kind of problems are noticed all over the world. Mississippi, Missouri, on the Rhine, on the Elbe. So the sediment is not coming anymore to rivers as it used to be. And that's also the problem on the seasides, because the sediment is not coming through the rivers in the sea, and we have a huge loss of beaches, which is a problem also all around the world. So we are changing the river basins. The use of the land is changed. There is so many settlements, so many paved areas, there are roads, there are railroads, everything is interrupting the sediment income. So this is not only the problem on this Velika Morava, but the huge problems are all around. And you cannot find the solution for that easily. You can build some kind of a structure in the riverbed which will stop the sediment and make it higher the water levels, but it is also a big environmental impact because you have to make a structure that will be possible for fish and so on. So it is when you make such, I cannot say mistake, but because nobody thought that it is mistake, but everybody was doing something, and the combined effect is not good.
But
I say.
if I may add to this question, another one, could we relate this to the climate change and, for example, the loss of height of the snow in or ice in the mountains? We know that there is a quite large increase in temperatures, and the precipitation of the snow during the winter is lower in the higher mountains. So
Yes.
maybe.
So I don't think so, because the snow melting is usually slow, and it doesn't produce the sediment input. You know, the sediment comes to rivers if you have heavy rains, and then you have a huge impact. But there is a change. Everything is changing, and it is changing very quickly. And I'm afraid that many such, I cannot say mistakes, but faults shall appear in the next decades. And our students will have to make some investigations and try to solve these problems.
Yeah, this is maybe another issue. As you showed us a lot of data for the historical, but maybe what are your predictions for the future, especially if you take into account the latest flood from 2014? I don't know what was the impact of these structures, or could we maybe prevent some damages that were done in this kind of really huge floods, and how we can deal with that in the future? And what is your opinion about the future? Now you said, okay, we need to teach the students.
Yeah.
Also,
when I started to work, it was easy, quite easy. We knew that the Danube will have a higher flows between March and I don't know, May, maybe June, if the source of snow was quite big in the Danube Basin. And also we knew that Sava will come first, because the melting will start in Sava first, then will come Tisa and the Danube, and it was quite easy to predict what to do. But the recent floods originate from heavy rains. No, not only on the smaller river basins, but on the Danube itself. It is the 2006 was the melting of the snow, but then we had 2013, which was extreme, and it was only by very high precipitation in the river basin. So you don't have any pattern. You can expect floods in any time of the year, and the combination of these tributaries, I'm very afraid, because Belgrade is on the mouth of the Sava to Danube, and a few tens of kilometers upstream is the Tisa. So all major tributaries are joining Danube here, and the combination of the floods of this river is very frightening for me, because in 2006 we had 100-year flood on the Danube, in Croatia also, you remember, and on the Tisa, and the combination of these two gave 100-year floods on the Iron Gate stretch of the Danube. But the Sava was not low, but not exceeding the full bank. So if the Sava was also 100-year floods, it would be a disaster, because it will be above the design flows. So that is my concern, that this is the climate change. So you cannot expect anything, but you can expect catastrophe of any time in any part of the country.
And as I said, maybe now the current hydropower plants, they are designed for the flood protection, and maybe mostly for the navigation and hydro for power production. But could we design them more now to be like provide us resilience to these floods, or there is no way to, for example, just to slow down the little bit Sava if we flood on purpose some parts of our.
Well, this must be the obligation of the hydropower industry, also to protect the downstream areas from flooding. And the only way is to use these reservoirs of any kind of these for hydropower production, or also these lowland areas as you have in the middle Sava. And we must build these capacities for future. Otherwise, I don't know what can happen. We had recently, few weeks ago here in Serbia, very heavy rains, which are, the intensity of the rains is so big that you cannot do anything. On these smaller rivers, there are floods which are unexpected by volume and by damage, because the flood came so quickly that nobody could react. So only if you have some retentions, if you have some reservoirs, it will at least for a while retain this water and stop this damage.
Okay, and if there are no more questions, I also have some.
I will also, I would like to go back a little bit to lowering the river level. You mentioned the potential solution as artificial, let's say, layers on the river bed to keep the sedimentation. So, but do you know, is there some successful attempts of applying this solution and technology, and what is the cost of such measures?
Well, it is not so costly, but it creates another problems. You know, you cannot resolve all the problems with one structure. You will initiate something else, because presently we don't have floods anymore on the Velika Morava. Not only in this part that I mentioned, but along the whole river, which is almost 200 kilometers long, because the riverbed is deepened and the floods don't endanger these areas. If you build a structure in the riverbed, then you will change these flood conditions, and somebody else will be angry about that. So I don't know. We didn't make any real study, any at least pre-feasibility study or something like that. So the problem remains open for the moment.
Okay, and
Thank
now
you
we
for your
got
detailed answer.
we got a question from anonymous attendee. I don't know how it's possible to come anonymously, but it's a quite interesting question. In addition to continuous monitoring of the Iron Gate, Zvornik and Velika Morava reservoirs, are there plans for future scenarios to analyze the climate, land, energy, water nexus?
Well, I would like to investigate all these scenarios and everything in advance, because it is easier to study, to model some scenarios than to only deal with consequences. But you know, it is difficult to find somebody to finance this, because all the authorities in a country which is not so rich as Serbia, they are only dealing with some burning questions. So if something must be done now, they are financing only that. Nobody thinks about the future, about the climate change, land use change. Everything is changing in this world, and I think that it is better to think in advance. So this kind of study will be most welcome from my side.
Yes, well, maybe I can agree with you that Serbia is not the richest country, but regarding the biodiversity and some of these cultural issues, you are very rich. So you are also protecting this, and this is what amazed me in your presentation, that of course there are certain benefits also from building these dams and structures, and you expanded certain ecosystems and bioreservoirs. So can we also look and plan for the future if we will have this climate change? Can we in this way somehow protect and provide biological minimum to certain regions or areas by building this more expensive, or even, I don't know, some other structures or channels, or I don't know how we could do that?
Yeah. Well, there are ideas, many ideas. I think that in future we will need water, for all kinds of use, and that we will have problems for flood protection. So the only way is to build reservoirs, small ponds, larger ponds, wherever you can, and keep the water for dry season, and also to use that for flood waters, to store them, to retain them, and so on. So that, according to my opinion, is that is the only way for the future. But it changes the environment, it changes the land use, and so on. So you must have the full view of all kinds of problems, sociological, environment, economy, everything else, when you plan measures for the future. But I would like to, to have that kind of a study, at least for one river basin. It should not be such a big river basin as Velika Morava, but one pilot, it will be good to know what can we do in both management of the low waters and high waters.
Yes, this is maybe also for me interesting option, because I don't know, are you familiar with the beavers, but they return to some rivers in Croatia, you know, and even in some smaller streams, etc. So I know they are building dams everywhere, and people are not happy. But do we have some research of that, maybe from the regions where beavers are for the longer time? How are their structures preventing some floods or stopping, or what is this kind of impact? And can we maybe count of this smaller, but
everything that can be done for the management of this water inflow, water retentions, and everything that can the landowners do on their own lands, like plowing, type of plowing the land, or the afforestation, whatever we can do to retain water in the river basin, it's good. So I really like to promote this kind of measure, although it should be promoted on the higher level. It should be promoted at least at the municipal or regional level, or something like that, because it contributes to the environment, and contributes to the flood management, to agriculture, to forestry. So everybody is happy, but nobody is promoting that on a wider public.
Thank you. And here is another interesting question coming from Shir Kilkesh. She are interested, would there be any additional views of collaboration based on the Danube River Basin Management Plan, which must involve all these countries that is Danube River connecting? So I think it's quite huge and demanding process, but very important.
The Danube River Basin Management Plan, we are collaborating on that. I was personally the member of the ICPDR groups on floods and on hydromorphology. And in this collaboration, the Iron Gate is very, very important. And the target for the next planning cycles is to make these iron gates dam possible for sturgeons and other fishes, especially for sturgeons, because they are flag animals for the Danube Basin. So when they come back to Danube, they think that the Danube will be again as natural, as I said. Something like that. but I sincerely doubt that it will be possible. Presently, we are doing some investigations, and hopefully the next step will be some kind of pre-feasibility study for the Iron Gate. The fish passage on the Iron Gate 2 is not a problem because the dam is low and there is enough space all around to make the fish passage. But the Iron Gate 1 is 40 meters high and there is no room for so only fish lift or some kind of catch and carry and so on. So presently the target is to make the Iron Gate dams passable in any way, but to restore this especially sturgeons in the Danube.
Thank you. Are there any other questions? Okay, now we really extended this lectures, and because it is quite interesting, informative, I'm definitely will try to read your book and see what other recommendations
Send me your address, I will mail it to you.
Okay, thank you.
But you can find it on the internet.
We will, yeah.
On the Yaroslav Cherny, our website, you can find it as PDF.
Yeah, this is what we are doing. And thank you very much once again for this excellent lecture, for your answers to the questions. And I would like to thank attendees for being with us. And I know that people from many parts of the world will listen and watch this lecture further. So maybe there will be some other questions that you will be able to answer. And once again, thank you for this presentation, and I wish you luck and everything best in the future for keeping and protecting our rivers and also the riverbanks and everything what goes with that.
Thank you. Thank you.
Thank you. Bye-bye.
Bye.